I would like to explain to you what is a 12 lead ECG and how we can measure it and how we're using the vectors to identify the electrical activity of the heart. I would like to simplify this. Let me do another drawing that might be better. Let me explain to you the Einthoven's theory. This is a head, and then we have the neck, and we have this guy with a long arm, and then we do this. This is a body. So let's say I have 4 electrodes. So this is the right arm, and this is the left arm, LA, and this is RA. Yep. And then I'm having electrode here and an electrode there. This is the left leg, and that is the right leg. I would like to show you something called the 12 lead electrode system. And when I say 12 lead, it means I'm going to obtain 12 voltages. Let's say this is the heart. We will build an instrument, the ECG instrument that we have in the hospital. And that instrument is going to be collecting information and then measuring voltages. I'm going to create the triangle. So this is a triangle between this electrode and that electrode, left arm and the right arm. It's like an invisible connection between the right arm and the left leg. And then I have this also connection. We have this triangle, right? And the right leg here is just the ground, right? So that is only ground for us. And that's the basic of the system that Einthovens have developed. I'm trying to look at the heart, and I would like to measure the electrical activity of the heart from different locations. So we said that this is between the left arm and the right arm. If you have 2 electrodes, in the ECG, the voltage from this location and that location is going to the ECG machine. The ECG machine will do some processing, smart processing, and then it's going to give us a voltage. We call it 1, the lead 1 voltage. And then the same device will take the voltage from RA and L left leg, and it's going to, and so before we do this lead, it's like we are reading the voltage of the heart, right? Sorry, but from this location, from the top. Does it make sense? So we're looking at the voltage from the head down so we're looking at the heart from the top, and we're measuring that electrical activity. If you use the right arm and the left leg, and you take these voltages from these 2 electrodes, send it to the ECG smart signal instrument, it will do some processing, and then it's going to give me the voltage reading of the heart 2 from that side. So that's lead 2. Same thing, it's going to take the left arm and the left leg, do some processing, and then it's going to give me a voltage that represents looking at the heart from this side, and that's lead 3. So I have 3 different readings of the voltage around the heart from 3 different locations. So it's if you think about it in 3-dimensional, think of the heart as a ball, and you're looking at the ball from the top and the right and the left. And you're reading that, and you're looking at that electrical activity from these sides. Those are 3. We're talking about 12. So where are the other ones? So here we have also something called AV1, which means it's the augmented voltage from the right arm. This location is far away from the heart. That's why I need to do some processing and magnification with an operation amplifier. That's what I called augmented voltage 1. And this is actually looking at the heart from below the arm, from this location. That's called AV1, right? So that's AV1. Also, we're looking from the left arm, and again, it's far away from the heart, and we need to make sure that we are augmented it. So we multiply it with a value using the operation amplifier, and I'm looking to the heart from this location, and that's called AV2. or oh, this is AV right. You can do it right, and you can say AV left, augmented voltage from the left, and the same thing happened here, AV from the left leg. So from this location, as if I'm looking at the heart from this point, and that's called AV left. So let's say um, this is right RA, this is left arm, and that is left leg. Augmented voltage left leg, augmented voltage left leg. So I have how many of them now? I have 6. So we said this is the human body. We have 1 electrode, 2 electrodes, 3 electrodes, 4 electrodes. If anyone goes to the hospital, they will be placing those first. Now, the 4th electrode, which is the right leg, that's the earth, and we're not going to use it. If we draw a triangle from the the electrodes that we build, we have the Einthoven Triangle. Now, the machine, the instrument, the ECG instrument, will take the voltage from the left arm and the right arm, and somehow is going to process it in a smart way, and it's going to give me a voltage as if we are looking to the heart from the top. Same thing will be the voltage from the left arm and the left leg will be taken through into the machine. The machine will do some processing, and then it will spit out a voltage for me as it's the third lead. Same thing for the second one, the right arm and the left leg. So I have 1, 2, 3 voltages coming just because of the processing from the device. Then the device will take this electrode on the right arm and measure the voltage on it only. Because it's so far away from the heart, it's going to multiply it with a factor. It's going to augment it. And we said AVRA. And same thing happened for the left arm, AV left arm, and then AVLL. And this is as if you're looking to the heart from the arms and the leg. So I have 6 views. So I'm looking at the heart from 6 locations in 3 dimensions and measure the electrical activity from those locations. Now, those are only 6. And we talked about 12 leads. So where are the other 6 coming from? If someone goes to the hospital, they will be placing chest electrodes. So we will have 1, 2, 3, 4, 5, and I think that's going to be another one here, 6. So we'll have 1, 2, 3, 4, 5, 6 electrodes placed around the heart, and these 6 electrodes are actually which complete the other 6 voltages to obtain a 12 lead system that will result in developing this ECG. So the output, when you add all of them together, the voltages, this is what will come up. PQRST waves, and U actually, but we care about the PQRST wave. And that's how we measure the voltages on the surface of the body. A human body in 3 dimensions, and the heart is in the middle. And I'm trying to look at the heart from different locations around it in order to be able to see what is happening from an electrical point of view. And you end up with a PQRST wave of the heart. Anything that is wrong anywhere in the heart, in any location, in the front, back, top end, or bottom, now we can see it and you can detect it in the ECG signal. And that's actually what right arm, left leg, right leg, and that's the triangle. I wanted to make the hands go a little bit away to show you what do we mean by augmented VRA, those voltages, and how will you get. So you can see that those are the vector representation of the voltages that we measure in the machine, and those are the surface electrode, the 6, 1, 2, 3, 4, 5, 6 around the heart, and you need to put all of them together. So the 3 augmented limbs are just 1, 2, 3, and the left leg, right? And you add them to the other ones. Yeah, and we call them AVL, augmented voltage left, AVR, augmented voltage R, and then AVF, that's augmented voltage foot. So here we can go. So that's, yeah, let me change this. And then we say F. augmented voltage foot, augmented voltage R, augmented voltage left. And those are the ones that we care about. And they're augmented because they are far away from the heart. And then you're looking at the heart from that side, from this side or the bottom. You see lead 1, 2, and 3. Those are the leads that we are looking from the top or the side or from the other side. So you have lead voltage 1, 2, 3. You have AVL, AVR, and AVF. Those are 6 leads or 6 voltages. You add the 6 on the chest, and you end up with a 12-volt view of the heart. A chest lead is used to obtain the ECG in the transverse plane. And then because of that, you get your signal, the PQRST wave.